Hello everyone, welcome to my channel. In the previous lectures, we have seen few solved examples on finding equivalent resistance. In all those problems, we have seen the combination of resistors either placed in series or in parallel form. In general, a resistors can be placed in series or parallels. Sometimes resistors can be placed neither in series nor parallel. At that instant, it is difficult to simplify the network by following the earlier approach. Let us see here. Alternate way of representing a combination of resistors can be a delta network or a star network. This is how delta network will be represented. So alternate form of representing delta network is like this. This is a pi network, and delta network has the symbol of triangle, and this is a star network. Star network has the symbol of Y. An alternate form of representing a star network can be a T network. If delta network is given, we can convert the delta network to star network. And if star network is given, we can convert star to delta network. Let us see the formula to convert delta network to star network and star network to delta network. Delta to star conversion formula. Here delta network is given and star network need to be found out. By drawing the figure, we can able to see what is a star network and what is a delta network. In delta network, we have taken the resistances as Rab, Rbc, Rac, and star network resistance values are Ra, Rb, and Rc. Given here Rab values, Rac value, and Rbc, and we can write the formula for star network resistances as Ra equal to Rab into Rac divided by sum of three resistances Rab plus Rbc plus Rac. To find Rb value, Rb equal to Rab into Rbc divided by sum of resistances Rab plus Rbc plus Rac. And to find Rc, which is equal to Rac into Rbc divided by Rab plus Rbc plus Rac. Here you can see in the figure. So in order to find Ra, multiplication of this adjacent resistors divided by total number of resistances, that is Rab plus Rbc plus Rec. In the same way, we can see other formula as well. So these are the formula which are helpful to find out star network resistance values using delta network. Now star to delta conversion. Here star network is given to you and you have to convert it to delta. That is, given values will be Ra, Rb, and Rc. Using these given values, we should find Rab, Rbc, and Rac. And it is given by Rab equal to Ra into Rb plus Rb into Rc plus Rc into Ra divided by opposite resistance Rc. If you see the figure, here we have Rab. Rab equal to multiplication of two resistors at a time plus Rab equal to Ra into Rb plus Rb into Rc plus Rc into Ra divided by opposite resistance, that is Rc. Next, Rbc equal to Ra into Rb plus Rb into Rc plus Rc into Ra divided by opposite resistance Ra. And Rac equal to Ra into Rb plus Rb into Rc plus Rc into Ra divided by opposite resistance Rb. These are the formula required to convert star to delta network. Let us discuss a problem now. Find the equivalent resistance across the terminals A and B. This is the figure given to us. We are supposed to find the equivalent resistance. So in order to find the equivalent resistance, let us understand what is there in the figure. We have here star connection and as well as delta connection. Now I would like to convert this star this star connection to delta conversion, or you can even convert the delta connection to star connection. It's your wish, but now I want to just convert this star network to delta network. So if I do so, I can rewrite the figure as I'm writing outer delta network as it is. So it is R ohms, R ohms, R ohms. Okay. Now I'm just converting this star to delta. So the formula for this is star to delta conversion. This value will be R into R, that is adjacent resistors multiplication, R into R plus R into R plus R into R divided by opposite resistance, that is R, which is equal to 3R square by R, that equal to 3R. So this is the value of 3R. Next, coming to this branch, as all the resistance values are equal, here also we can write 3R because same will be applicable. R into R plus R into R plus R into R divided by R, that equal to 3R square by R, which is equal to 3R. Next, this branch, this is also 3R. Okay, we have converted this star network to delta network. The branches obtained to the delta network of this are parallel to the existing branches. So this 3R is parallel to this R, this 3R is parallel to this R, this 3R is parallel to this R. So here you can find out the equivalent resistance of each and every branch here. So the equivalent resistance for this is R into 3R divided by R plus 3R equal to 3R square by 4R equal to 3R by 4. And even here these two are parallel. Equivalent resistance will be 3R by 4. Even these two resistances are in parallel. So the value will be 3R by 4. Let us redraw the circuit. Circuit becomes 3R by 4, 3R by 4, 3R by 4, right? The terminals will be A and B. We can alternately draw this circuit. We can alternately draw the circuit as like this: 3R by 4, 3R by 4, 3R by 4. Okay, from the figure we can see now these two resistances are in series because there is no current division taking place across these two resistors. You can consider these two are in series. When these two are in series, we can find equivalent resistance as R equivalent equal to 3R by 4 plus 3R by 4, which is equal to 6R by 4, that equal to 3R divided by 2. I would like to redraw the figure now. terminals A, B, this is 3R by 4 and new value as 3R by 2. Now you can see these two resistors are in parallel. So we can write R equivalent or RAB equal to 3R by 2 into 3R by 4 divided by 3R by 2 plus 3R by 4. If you solve this equation, the answer will be R by 2. Therefore, R equivalent or RAB equal to R by 2 ohms. This is the answer. Let us see the next problem. For the interconnected resistor shown in figure, find the net resistance between the terminals 1 and 3. We are supposed to find the equivalent resistance between the terminals 1 and 3. And here we have 4 delta networks. Whenever you have 4 delta networks, at a time you solve or you convert any 2 delta networks into star networks. So I want to choose here this delta network and this delta network for conversion process. So let me redraw the figure. So write the terminals 1, 3, 2, and here this is 4 and this is 5. So you should convert this to star. So internally I am writing this, and even here star. Okay, write the resistor value 68 by 3 ohm, 12 ohm, 12 ohm, 12 ohm, 8 ohm, 12 ohm, 12 ohm, and this is also 12 ohm. Okay, we know the formula for delta to star conversion. Using the formula, we can write each and every element value. Here, this delta network has the resistances which is of equal value, even here which is of equal value. So if you find any one of the resistance values, obviously the others will be equal. So for this, we can write according to formula 12 into 12 divided by 12 plus 12 plus 12, which is equal to 4 ohm. For this resistance, 12 into 12 divided by, I'm just applying the formula which we have discussed earlier, equal to 4 ohm. Even for this, 12 into 12 divided by 12 plus 12 plus 12, which is equal to 4 ohm. For this, 12 into 12 divided by 12 plus 12 plus 12, 12 into 12 by 12 plus 12 plus 12, 4 ohm. Even here 4 ohm. This is also same, 12 into 12 by 12 plus 12 plus 12, that equal to 4 ohm. Okay, let us redraw the figure now. This is the 4 ohm. After drawing figure, we have to simplify it further. So, okay, Now let us write the values here. Just take the help of previous figure. This is node 1, this is node 2, this is node 3, and the bottom one is node 4. Okay. Here you can see this is here 4 ohm resistor, and even here 4 ohm resistor, and this is 8 ohm, 4 ohm, 4 ohm, and this is a node 5, and this is a 4 ohm resistor, 4 ohm resistor, and this is 68 by 3 ohm. Okay, so this 68 by 3 ohm resistor and 8 ohm resistor remain same, all other are 4 ohms. From the starting figure you can see this 68 by 3 ohm is same and 8 ohm is same. All other network have been converted to star networks. So from this figure we can put more node points, and I want to just number this node point as 6 and this node point as 7. Okay, from this figure I can see that 4 and 8 ohm resistors are in series. So I can replace this with R equivalent value. R equivalent equal to 4 plus 8, that equal to 12 ohm. Okay. I'll redraw the figure now. And one more point, even here you can see 4 ohm resistor and 4 ohm resistor are in series. We can replace even with this as 4 plus 4, that is 8 ohm. I'll reflect the same changes in the next circuit. So this is 4 ohm. Okay, this is 68 by 3 ohm, and this is 8 ohm, and this is 12 ohm, and this is 4 ohm. This is node 1, node 6, node 7, and node. So this figure has been simplified like this. And now from this figure we can see again two delta networks. This is one delta network and this is one delta network. Let us convert one of the networks to star. I would like to choose this delta network to convert to star. Okay, and I'll use formula in order to convert it. This equal to 12 into 4 divided by 12 plus 8 plus 4, which is equal to 2 ohm, and this value equal to 12 into 8 by 12 plus 8 plus 4 equal to 4 ohm, and this value equal to 8 into 4 by 12 plus 8 plus 4, which is equal to 1.33 ohm. Okay, let us redraw the figure again now. So this is node 1, node 6, and node 7. Okay, and let this be node 3, and here this is 4 ohm and this is 68 by 3 ohm as it is, and from the values we can write this is 1.33 ohm, and here this as 4 ohm and this as 2 ohm. Okay, next, from this figure you can see these two resistors are in series. Okay, same current flows in these two resistors and these two resistors are in series. Again we can write equivalent resistances for these two resistances as R equivalent equal to 4 plus 4, that equal to 8 ohm, whereas here equivalent resistance equal to 68 by 3 plus 1.33, which is equal to 23.99 ohm. I'll take 24 ohm. I'll redraw the figure. So this is 8 ohm and this is 24 ohm. 1 and this is 3. Okay, terminal. And we have here 8 ohm and we have here 24 ohm, and this value is 2 ohm. And it is very clear that these two are in parallel, which is in series with this 2 ohm resistor. So R equivalent for this is 8 into 24 divided by 8 plus 24. If you do so, we get here 6 ohm. So the final circuit can be drawn as, simplified one can be drawn as 1 terminal 3, and this is 6 ohm and this is 2 ohm. And we can write R equivalent equal to R R1 3 resistance across 1 3 terminals is given by 6 plus 2, which is equal to 8 ohm. So 8 ohm is the answer. That's all for this video. Thank you.